Well, I got so close to finishing in that last video. Nearly got there, but anyway, so I'm just going to finish this question off here to begin with. So we've got two of them, we're taking away 2/3, so that leaves us with 1 1/3 of these things, which is just the same as 4/3 at the front of the square root of 8/3. And remember that that's measured in meters because it is the displacement. Anyway, that's all for the first question. I'll just quickly get the other one set up and then we'll get back onto it again. Righto, got that all taken care of. So we need to find the stationary points of these two equations here. And the first one I'm actually going to do without even using differentiation at all. I'm just going to just do it by knowing what the graph looks like and having a pretty good idea about how it's all going to sort of come together. So the first thing I'm going to do with this one here is I'm going to figure out the period of the function is 2 pi on 3. And if I just do a really quick sketch of the graph, what that means is that it's a sine function, so it's going to start here. It hasn't got any vertical translations or horizontal translations. And it's going to go up and down and back up in the space of 2 pi on 3. So what that means, because of the symmetry, is that this here is pi on 3. And if that's 0 and that's pi on 3, then that makes this half of that, which is pi on 6. So that's pi on 6, 2 pi on 6. This part here is going to be 3 pi on 6, which is the same as pi on 2. And then we've got 4 pi on 6, and the next one would be at 5 pi on 6. So what I can say then is that x is equal to pi on 6, pi on 2, and 5 pi on 6. Those are the three places over the domain of 0 to pi where we get maximum and minimum points. And we can see that it's a local maximum at pi on 6, a local minimum at pi on 2, and then the local maximum again at 5 pi on 6. And it says to find stationary points. What that kind of implies is that we have to actually get the coordinates of the point. So what this pi on 6 is going to give is a value of positive 1. So we've got pi on 6 and 1. We've got pi on 2 and negative 1, because it's below the axis there. And we've also got 5 pi on 6 and positive 1 again. And those are our three stationary points over that interval. For the next question, we've got x times log e of 2x over the domain 0 to infinity. So because it's being multiplied here, I need to use the product rule to differentiate. So straight away I'm going to go u equals x, and du dx equals 1, and v equals log e of 2x. So dv dx is going to be 2 over 2x, which just simplifies to 1 over x. And I can say then that f dash x is equal to u dv dx plus v du dx. So in that case, we've got x times 1 over x, which the x's will just cancel out and leave 1. Then we've got v times du dx, so that's just log e of 2x. Okay, next, remember that we need to let the gradient equal 0. So let f dash x equal 0. And from there I can write 0 equals 1 plus log e of 2x. I'm going to minus 1 on both sides. So log e of 2x is equal to negative 1. Need to do e to the power of on both sides. So I get 2x equals e to the power of negative 1, which is the same as 1 over e. So 2x equals 1 over e. And then just divide by 2 on both sides to get x equals 1 over 2e. When x equals 1 over 2e, we need to solve it back into the original equation. I'm going to run out of time again. Anyway,